Hi. So recently in the newspaper, there was a controversy about an unsolvable metric maths paper. And apparently the pupils couldn't solve it, and it resulted in a lot of tension, anxiety, and drama. So here's the question. Given that the square root of 13 times sine of x plus 3 is equal to 0, where x is presumably inside these 2 points, without using a calculator, determine the value of sine of 360 plus x, tan of x, and cos of 180 plus x for 2, 3, and 2 points. So the issue is that there is apparently inconsistent or contradictory information at first glance. So that could be a possible issue. There is a professor, and they say that the first condition, which is this expression, requires that sine be negative. Even if you draw a graph of sine of x, for sine to be negative, it must be between 180 to 360 in the third or the fourth quadrant. However, the second piece of information that x is in 0 to 90, the interval, is inconsistent. So at first glance, it is mutually contradictory or inconsistent information. You can't have both possible conditions to be true. Therefore, if both possible conditions cannot be true at the same time, the problem is impossible to solve. And the only way to make the problem solvable is either there's a typo where instead of having um, root 13 sine plus 3 equal to 0, you have root 13 sine minus 3 is 0. Alternatively, if you adjust the range to say x is in 180 to 360 as opposed to 0 to 90. That is one possible interpretation. But there's another possible interpretation. Here's how we can look at it. So the same problem, and we have the information root 13 sine x plus 3 is 0, and where x is an element of that. Now, the notation x element open round bracket 0 semicolon 90 degrees close round bracket, mathematically that doesn't really make sense. Why? Well, typically if you have a round bracket, it means it does not include the elements on the side. To include the elements mathematically, you have to have a square bracket. Then there's a semicolon. A semicolon doesn't really make mathematical sense. If you wanted an interval or a range of possible values, you would put a comma, not a semicolon. So, as best as can be ascertained, when you have a semicolon, you have two elements in the set. With the round brackets means x cannot be equal to either of the two elements. So it's a very weird mathematical notation, at least for an engineer. And as far as can be ascertained, this weird expression means x is not 0 degrees and it's not 90 degrees. Okay, if you use that second piece of information in this weird inconsistent notation, what you're left with is root 13 sine x plus 3, 0. Rearrange, sine is minus 3 over root 13. Therefore, if sine is negative, the angle must be between greater than 180 degrees but less than 360 degrees. That means it must be either in the third quadrant or the fourth quadrant. You draw a picture, first quadrant, second quadrant, third quadrant, fourth quadrant. We have sine using your high school maths, SOHCAHTOA. Sine is opposite of a hypotenuse, cosine is adjacent of a hypotenuse, tan is opposite of adjacent, so COTOA. And the available information, it's either in the third quadrant or in the fourth quadrant. Opposite, minus 3 over root 13, or minus 3 over root 13. If x is in the fourth quadrant, you just use the negative angle. If x is in the third quadrant, you would have to use the obtuse angle. So the question says without using a calculator. So this is where you have to make an assumption. You assume that the angle x is acute. In other words, x is in the fourth quadrant. Because if it was in the third quadrant, you wouldn't really be able to solve it by hand. And the question says you need to solve it by hand. So assume it's in the fourth quadrant. The opposite side is minus 3. Root 13 is the hypotenuse. The hypotenuse is always positive. Then you use Pythagoras' equation. This is the hypotenuse, this is the opposite, this is the adjacent. You work out an adjacent to be plus or minus 2. But you assumed that the angle is in the fourth quadrant. Therefore, for it to be in the fourth quadrant, the adjacent has to be positive 2. And then that's the problem solved. So sine of 360 plus any angle will just be sine of that angle. And we already know sine of x, which is minus 3 over root 13. That's the answer. Tan is opposite over adjacent. This is the opposite, minus 3. The adjacent is plus 2, so it's minus 3 over 2, which is minus 1.5. And cos of 180 plus x is always, by our trig rules, minus cos of x, which we don't need a calculator for. Cos is adjacent over the hypotenuse, so the adjacent is 2, the hypotenuse is root 13, and it would be the negative of that, minus 2 over root 13. And these are the answers. And then if you check with the calculator, you get exactly the same answer. So the notion that the problem is impossible to solve based on the statement, the problem is impossible to solve if you don't know and are not able to infer the meaning of this slightly weird mathematical notation. The problem is not inconsistent if you realize that the round brackets do not mean x is in the range from 0 to 90. That's the trick. They didn't put the square brackets, they put the round brackets. Therefore, the problem is potentially solvable. So it would take about half a page of reasoning in an exam, and it could be solved by hand without a calculator if you logically reasoned it through. That being said, the reasoning is a little bit perhaps too challenging for high school students, and the problem is badly phrased. So it is phrased in a very odd way, but it's not necessarily phrased in an incorrect way. All right, that's the end of the video.